This is the solution video for section 4.2, problem number 8. So the directions here say, determine if f satisfies the conditions of the mean value theorem. If so, find all possible values of c. All right, so problem number 8 says f of x is 0.2 x squared plus sine of x on the interval -1 to 2. And hint, use your calculator. All right, so first thing we're going to do is determine if f is continuous. So remember, I have two pieces here added together. So if each one of these is continuous, then the result is continuous. So 0.2 x squared, that's a quadratic. Of course, that's continuous. And sine of x, that is continuous, right? No jumps, asymptotes, holes, anything like that. All right, and so then we want to think about the derivative. So f prime of x. All right, derivative of 0.2 x squared. Well, 2 times 0.2 is 0.4 x, okay, plus the derivative of sine, which is cosine of x. Of course, 0.4 x, that's continuous everywhere, and cosine is continuous everywhere. And so what does that mean? That means that f is differentiable upon the open interval -1 to 2. All right, so the mean value theorem does apply, right, because this function is continuous and differentiable. Therefore, we want to remember what the mean value theorem says. So mean value theorem says f prime of c is equal to f of b minus f of a over b minus a, right? So remember, the interval -1 to 2 is a to b. All right, so f prime of c, so 0.4 c plus the cosine of c is equal to f of b. So that would be f of 2 minus f of -1, all divided by 2 minus -1. All right, so on the side here, I'm going to determine what f of 2 is. So that would be 0.2, sorry, not 0.4, 0.2 times 2 squared plus the sine of 2. F of -1 is going to be 0.2 times -1 squared plus the sine of -1. All right, so I'm going to have 0.4c plus the cosine of c equal to f of 2, which is going to be this 0.2 times 2 squared, so that would actually be 0.8, so 0.8 plus the sine of 2. So I'm going to have that minus this other thing. So 0.2 times -1 squared, that would just be 0.2, and then plus the sine of -1. Now, it's important to remember that you need to distribute that negative sign and then divide it by 3. All right, so now I'm going to solve using my calculator. So I'm actually going to type in the following into my calculator. I'm going to put this as y1, and I'm going to put this thing as y2, and then I'm going to set them equal to each other and solve. All right, and so I'm going to do that. All right, and I end up with, all right, y equals, all right, so in y1 I'm going to type 0.4x plus the cosine of x. So important to remember that you are plugging in the variable x, right? But you're using a cosine, so any trig function, you want to make sure your mode is correct. I'm using the radian mode, all right? And so in y equals, I have that, all right? And then I go to my y2, and I'm going to type this other thing. So I'm going to use parentheses for the numerator. So 0.8 plus the sine of 2. In my work there, it looks like I wrote tangent, but I think that's plus sine of 2. All right, and so I have, now I'm going to subtract 0.2, so minus 0.2, and then I'm going to also subtract the sine of -1. All right, then I have to close the parentheses on the numerator and divide it by 3. All right, so now I'm going to hit, normally your standard window looks like this. Now you can see that there are some intersections there, but we only want the intersections between -1 and 2. So I'm going to go to my window and I'm going to set the x minimum to be -1 and the x maximum to be 2. All right, but now when I hit graph, it still is kind of hard to see. So I want to change my y's as well. So let's maybe say we go from like -2 to 2, and then maybe you adjust further depending on how it looks. But right now, looks rather nice. We've got an intersection there, and we've got an intersection there. So we will use second trace intersect, so number 5. All right, so now first curve is y1, yes. Second curve is y2, yes. So now, do I need to guess? Well, yes, there are two different intersections. So I need to type something in that's over here, closer to the one on the left, so maybe like negative 0.5. All right, so if I do that, I'm going to get that intersection. And so we end up with x equals negative 0.371. So I'm going to write that over here. X equals negative 0.371. All right, and then I do it again. So then I'm going to do second trace 5. All right, first curve is y1, yes. Second curve is y2, yes. So now I need to guess something over here. How about like 1? And so I do that, and I get 1.307. So x equals negative 0.371 and 1.307. Now, of course, you want to make sure that these are only between negative 1 and 2, but I did that already by making sure that I set my window on my graph to be from negative 1 to 2.